All right, so today we're going to talk about 4-6 systems of linear equations with 3 or more variables. Now, just like we saw in the previous section, if you've got an equation with 3 variables and it's a linear equation, when you graph that, you get a plane. Just like when you graph an equation, a linear equation with 2 variables, you get a line. 3 equations, you get a plane. A plane is like a 3D version of a line. So it's a linear equation with 3 equations. And we've graphed some planes. Okay, now when you've got 3 planes, you think about how 3 planes are going to intersect, if they all in fact do intersect. Now you could have planes that are all parallel. That'll never intersect. You could have 2 planes that are parallel and the third one that's not parallel. So that plane will cut through the 2 planes and their intersection. First of all, there's no intersection of all 3, so there will be no solution to the system, no ordered triples, x, y, z, that satisfy all 3. So in order for 3 planes to intersect, they would intersect in a point. So you can think about, 2 walls in your house and then the floor. And those 2 walls, which you represent planes, will intersect in a line. And then the floor will intersect that line in a single point. So like a little corner of your room. And that point is represented by an ordered triple. Okay, so that's what we're looking for if the 3 planes do in fact intersect. So what we need to do, we can't do this all in one step, okay? We're going to take 2 of the equations, like let's say equations 1 and 2, and we're going to eliminate a variable, okay? And then we're going to take 2 other equations. Okay, let's actually do this one first, the way it's set up on the page. Let's take the first equation and the third equation. Looks like the first equation and the third equation, that 2y and negative 4y might be easy to eliminate. So if we call this equation 1, this equation 2, and this equation 3, we're going to take equations 1 and 3. And from those 2 equations, we're going to eliminate y. Okay, so what happens if we take the first and third equation, we're going to eliminate y. And what's left, we're going to get an equation that just has x's and z's in it. Okay, our second step is we're going to take another pair of equations. It doesn't matter what pair, but if we took 1 and 3, now we either have to take 1 and 2 or 2 and 3. Obviously, you don't want to take the same pair of equations. So let's just take the first 2. It looks like the first 2 we can eliminate the y's again. So take equations 1 and 2, and we're going to eliminate y again. That's going to give us a second equation that has no y's, that only has x's and z's. So after we do these 2 things, we're going to have 2 equations that only have x's and z's. And then we can solve that system, because we can solve a system with 2 equations and 2 unknowns. Okay, so we're going to take the first equation, this is equation 1, which was 3x up here, plus 2y minus 4z. We multiply that one by 2 and leave this one alone. The 2y will become a 4y, and then I'll cancel with the negative 4y. So multiplying the first equation by 2, we're going to get 6x plus 4y minus 8z equal to 2. I tried to line up the x's, y's, and z's with equations 3. Okay, so we're going to take this equation and this equation, add them together. 6x plus 2x gives us 8x. 4y minus 4y, those go away. Negative 8z plus 3z gives us minus 5z. And then 2 plus 17 gives us 19. So just like I said, we took these equations, we eliminated y, we got an equation with just x's and z's. So let's call this 8x minus 5z is equal to 19. That's going to be equation 4. Okay. Now we're going to take equations 1 and 2. Equations 1 and 2. We're going to multiply the first one by 3 and the second one by 2 so that we can eliminate the y's. First one by 3, second one by 2. So you get 9x plus 6y minus 12z is equal to 3. This one we're going to get 10x minus 6y plus 14z is equal to, and we need 2 times 28, 56. Add those together, the y's cancel, which was our goal. So we've got 19x plus 2z is equal to 59. Okay, we're going to call this one equation 5. So equation 5 will be 19x plus 2z equal to 59. Now we're going to take these two equations, equations 4 and 5, and we're going to eliminate something. I think the z's would be easiest to eliminate, but let's take equation 4, which is 8x minus 5z equal to 19, and take equation 5, which is 19x plus 2z is equal to 59. We're going to take the first equation and multiply by 2. Second equation, multiply by 5. Okay, so 2 times the first equation gives us 16x minus 10z equal to 38. Second equation times 5. 5 times 19, well, 5 times 100, 5 times 20 is 100, so it's going to be 5 less than that. So 95x plus 10z is equal to 5 times 59. 5 times 50 is 250. So 295. You add 5 times 9. Okay. Add those together. The z's will cancel. 95x plus 16x gives 100. And 11x equal to 295 plus 38 is going to be 335. Is that right? Let's just double check that. That's sorry, that's 333, not 335. Okay, that works better. Dividing by 111, you'll get x equal to 3. Okay, now we have x equal to 3. We can plug this back into either of these equations and solve for z. Let's plug it in here. 19 times 3 plus 2z equal to 59. 19 times 3 is 57 plus 2z equal to 59. 2z is equal to 2, so z equals 1. Let's go back to one of our original equations up here. Let's just use the first one, which was equation 1, which was 3x plus 2y minus 4z equal to 1. I know you can't see that, but I just wrote this down here. Okay, and now we know x is 3 and z is 1, so we're going to solve for y. So 3 times 3 plus 2y minus 4 times 1 equal to 1. So we get 9 plus 2y minus 4 is equal to 1. 2y plus 5 equals 1. 2y equals negative 4. Y equals negative 2. And again, make sure you give your solution as an ordered triple. 3 comma negative 2 comma 1. Okay. And let's go ahead and check this on the calculator. Okay. We did solve system. This is just going to be a little bit different to solve the system, but to verify, because this is 3 equations, 3 unknowns. So let's go to our calculator. Let's open a new page. We'll just open a calculator page. And we'll do solve system. So that's under menu, algebra, solve system of equations. Okay, actually, did we skip something? Let me try that again. Oops. Menu, sometimes it's, okay, cancel. Let's do that again. Menu. Sometimes it's easier to hit the numbers. So we'll do algebra 3. Solve system is 7. Solve system of linear equations, which is 2. That's going to make it a little easier for us. Now, how many equations do we have? We have 3. And once you type in that 3 and hit tab, it's going to default to x, y, and z. And that's what we have. So we'll go to OK. Now we'll type in our 3 equations, which were 3x plus 2y minus 4z equals 1. Back to the next one. 5x minus 3y. 5x minus 3y plus 7z equal to 28. And we've got 2x minus 4y plus 3z equal to 17. And hit enter to solve the system. And what do you know? You get 3, -2, 1. Okay, which was the same thing that we got when we did this algebraically. All right, till next time.